On Christmas Eve 2024, while the world celebrated under winter skies, a lone spacecraft no larger than a compact car was racing through the void. Its speed, an astonishing 430,000 miles per hour, faster than any human-made object in history. This was NASA's Parker Solar Probe, a marvel of modern engineering, built to go where no machine had dared before. Not merely near the Sun. Inside it. The probe was plunging into the solar corona, the Sun's outer atmosphere, where temperatures soar into the millions, and magnetic forces writhe in ways that defy imagination. At a distance of just 3.8 million miles from the surface, Parker wasn't observing from safety. It was flying through the very substance of our star. Streams of plasma swept past. Magnetic storms twisted and snapped around it. And for the first time in human history, we weren't just looking at the Sun. We were inside it. What Parker recorded was breathtaking, yet unsettling. Using artificial intelligence to decode its final and most daring images, scientists uncovered phenomena that shattered long-standing models of solar physics. Massive eruptions collided in deep space. Magnetic structures spiraled like cosmic dancers. Violent switchbacks twisted the solar wind into impossible shapes, challenging everything we thought we knew about energy flow in the corona. Then came something even stranger. 3 colossal coronal mass ejections erupted within hours. Instead of drifting apart, they collided, merging into a single monstrous wave of plasma and magnetic energy. Its combined force dwarfed anything ever observed. Had such a storm been aimed at Earth, the results could have been catastrophic: satellite destruction, collapsed power grids, disrupted communication, and deadly radiation exposure for astronauts. Parker's cameras also revealed the vast current sheet, a spiraling boundary where the Sun's magnetic field flips from north to south. Stretching billions of miles across space, it governs the flow of solar wind and dictates how storms interact with planetary shields. Near the Sun, Parker showed, this sheet is turbulent and unstable, constantly reshaping itself. And its behavior may determine whether Earth experiences harmless auroras, or planet-wide technological blackouts. Even more mysterious were the switchbacks Parker had first glimpsed in 2018. Zigzags in the solar wind once thought random. Now they appeared clustered, repeating, even synchronized with eruptions. Some scientists believe they could be channels funneling heat into the corona, finally explaining why it burns millions of degrees hotter than the surface. But there's a darker possibility. Switchbacks may amplify eruptions, triggering the most destructive solar storms imaginable. To survive its journey, Parker relied on Venus for repeated gravity assists, slingshotting closer with each pass. Its heat shield endured 2,600 degrees Fahrenheit, 1,400 degrees Celsius, while radiation levels bombarded its instruments at intensities that would destroy most spacecraft in seconds. Yet it returned more data than anyone had dreamed possible, so much that only AI could reveal the hidden patterns. Among them, a near-vacuum corridor carved in the solar wind after CME collisions, a magnetic heartbeat, pulsing every 142 minutes from deep inside the Sun. And a plasma filament 2 million kilometers long, unstable, threatening to erupt with power rivaling the legendary Carrington event of 1859. And then came the most enigmatic finding. Buried in Parker's radio signals was a narrowband transmission unlike any known natural or instrumental source. Not from the Sun. Not from Earth. But from the very space around the probe. Some argue it is plasma resonance, amplified by the Sun's magnetic field. Others whisper it may point to physics we do not yet understand. The Parker Solar Probe was never meant to return. Its mission was a one-way descent into the most hostile environment our species has ever dared to enter. And yet, in its final moments, it delivered discoveries that will reshape solar science forever. merged eruptions forging megastorms. A magnetic heartbeat within the Sun. A plasma filament on the brink of collapse. And a signal we cannot yet explain. Together, they reveal a star that is not constant but alive, unpredictable, and dangerous on a scale we are only beginning to grasp. The Sun has always been our source of life. But Parker's data reminds us, it is also a threat, capable of unleashing forces that could cripple our civilization. And as we face this truth, one thing becomes clear: understanding the Sun is no longer just science. It is